Okay, let's talk about the energy today. The first, let's review some scientific theorems about energy. The first one is the definition of energy. Energy is the capability to work. Okay, capability to work is energy. The total energy in the universe does not change. Energy cannot be created or destroyed. There are two types energies. One is called potential energy, and another one is called kinetic energy. Potential energy is stored energy, such as chemical energy stored in food. Kinetic energy is the energy in motion, such as a running machine. The energy units are calories and joules. Okay, 1 calorie equal 4.184 joules. Okay, this is the units. All right. Next, let's take a look at these energy changes in chemical reactions. Okay, the couple things that we should know. The first, breaking a bond requires input of energy. Forming a bond release energy. Okay. When energy is absorbed in the reaction is said to be endothermic, and the enthalpy change is a positive delta H. Okay, the enthalpy change is a positive as the endothermic. The reaction absorb energy. In endothermic reactions, the energy required for breaking bond is higher than the energy released from forming a bond. The bonds in reactants are stronger than the ones in the products. Therefore, additional energy is required and the products are less stable than reactants. That's endothermic reactions. Okay, they require additional energy, and the products are less stable than reactants. When energy is released in a reaction, the reaction is said to be exothermic. The delta H, okay, the enthalpy change is negative. In exothermic reaction, the energy released by forming bonds is more than energy required for breaking bonds. Therefore, additional energy is released. The products are more stable than the reactants. Okay, two types of reaction in terms of energy. Okay, if it's the energy required for the reaction is called endothermic. If the reaction release energy is called exothermic. Okay, this some things we should know about the energy. Next, let's take a look at this energy diagram. Reaction energy diagram. Let's take a look at the reaction. Okay, and what happened to the reaction. What's really happened behind the reaction? Okay, that's what happened. In a reaction, the particles of reactants, including atoms, ions, or molecules, collide in order to initiate a reaction. Okay, so the particles have to hit each other, and the kinetic energy of reactants must be high enough, okay, to break bonds, okay, to start the reaction. The minimal level, energy level at which reaction takes place is called a transition state. The transition state. The energy difference between an initial energy level of the reactants and the transition state is called energy activation, energy of activation, EA. The energy difference between reactants and the products called enthalpy change, delta H. Okay, just like say if it's enthalpy change is negative, it's exothermic. They release heat, and the product energy level lower than reactant. If the delta H is plus, it's endothermic reaction. They require energy, absorbing energy. The product energy level is higher than the reactants. Let's take a look at those diagrams here. Okay, the first one, let's take a look at this exosomic reaction. Okay, exothermic, they release energy. Okay, the reactions release energy. Let's take a look at those. What's it look like? This y-axis is the energy. Okay, increasing. Okay, this x-axis is the reaction coordinate. Okay, and this here. This is the reactant energy level. This is the product energy level. Okay, you can see reactants energy level is higher than the product's energy level. That's why the reaction release energy. Okay, this here is called transition state. Okay, this is energy of activation. That's the energy required to start the reaction. Okay, so you have to input energy activation first, then let's come to the minimum of energy required for the reaction, then the reaction starts. After starting the reaction, then they slowly release more energy. Okay, in total, the energy released from here to here is more than the energy of activation, more than the energy input. Okay, so the difference, okay, between reaction level, energy level, and the product level called delta H. If this reactant energy level is higher than the product, it's minus, so it's exosomic. Okay, so next is endothermic. You can see endothermic. It's a similar pattern, but the reactants energy level is lower than product's energy level. Okay, that's need much more energy to start the reaction. Okay, then release the action. The release the energy. The energy released is smaller than the energy required, so that's called endothermic. In general, the total energy is required, okay, for entire reaction. So this is the difference. Okay, if the reactant has lower energy and the product has higher energy, the delta H, the enthalpy change is plus. Okay, this is endothermic. Okay, plus delta H. Okay, the reaction requires more energy to start. Okay, next, let's take a look at this reaction rate. Reaction rate, chemical reaction occurs when the molecule collide. Okay, reaction rate depends on the frequency of molecule collision, which are determined by number of reactants and moving speed, the kinetic energy of the molecule particles. There are two factors affect the reaction rate. One is when you increasing concentration of reactant. Okay, the increase the frequency of the collision, and the rate increase. When you increase the temperature, the kinetic energy of reactants, the rate increase because they increase the kinetic energy. Okay. The next factor that can increase the reaction rate is called a catalyst. A catalyst is a substance that speeds up reaction without any chemical change on itself. The mechanism of a catalyst and catalysis is lowering transition energy. Let's take a look at this cartoon here. Okay, you can see originally the activation energy is higher. It's EA. Okay, this is a transition state original. Once the catalyst is used, okay, this green colored curve is when the catalyst is used. The transition state is much lower, much less energy activation required. This EA power prime is the energy of activation when the catalyst is used. Okay, that's what happened to the catalysis. Okay, reduce catalyst reducing the transition states. Okay, so the energy activation required is much lower. So, okay, that's what happened.